From the last previous videos, we are talking about indeterminate forms and L'Hopital rule. But there are some very strange forms appear as an indeterminate form. These forms are written over here. We already discussed that these are indeterminate form, which means that if we have 1 raised to power infinity, the answer cannot be equal to 1 or the answer cannot be equal to infinity and so on. So we are going to solve these indeterminate form by using L'Hopital rule. And if you remember that the L'Hopital rule says that if we have limit x approaches to a, f of x, g of x, then the L'Hopital rule says that we have to take a derivative of numerator, then denominator, then we solve this problem and we get the answer. But the problem with that 1 raised to power infinity is there is no numerator and there is no denominator. For example, this is a problem that we will solve by using L'Hopital rule. As you can see that when we apply limit over here, we get 1 raised to power infinity. How this comes? When we apply x approaches to 0, we get 1 plus 0, 1 divided by 0, 1 plus 0 is 1, 1 over 0 is infinity. So we get 1 raised to power infinity as an answer. Not the answer, but indeterminate form over here. So there must be some kind of trick that tells us how to solve this indeterminate form and convert that thing into the numerator and denominator form, which is a fractional thing. For that, in mathematics, for example, one limit x approaches to a, natural log of f of x, and that is equal to L. Suppose we have uh, this problem. What we can do, we want to find out f of x from here. The simple rule is you apply antilog. Limit x approaches to a, e raised to power natural log of f of x is equal to e raised to power L. So we have applied the antilog. This is a bit confusing for the students. The reason is when we want to find out the identity for 2, we multiply this with reciprocal 1 by 2 and we get the answer 1. If you want to get from natural log of f of x as f of x, if you want to get f of x from this expression, you cannot multiply this with 1 over antilog, which is e. Remember that the antilog of natural log of e. Natural log of e, this becomes equal to 1. Okay. So from natural log of f of x, if you want to find out f of x, you simply take this natural log into the power of exponential. That's how we do it. Whenever you are asked to find out x from here, take this into the power of exponential. That's how things become, and you just cancel out e and natural log of x together. Okay, now we have taken antilog on both sides. We know that antilog and log cancel out, and that power will come down. So we have limit x approaches to a, f of x, that will be equal to e raised to power L. Okay, so by using this trick, we can solve the following example 1. First thing we notice, natural log of f of x. So what we do? First of all, we take anti-log on both sides. Suppose we have f of x. We should define f of x first. Suppose we have f of x is equal to 1 plus x raised to power 1 over x. We apply natural log on both sides. Natural log of f of x is equal to natural log of 1 plus x 1 over x. Then the right hand side can become 1 over x natural log of 1 plus x. So we have transformed our given problem, this problem without limit, maybe this one, and we converted that into the natural log, the problem in natural log. Now we apply the limit as required from our question. Limit x approaches to a, natural log of f of x, that is equal to limit, not a, it should be 0, x approaches to 0, natural log of 1 plus x divided by x. Now we apply the limit. When we apply the limit, we get natural log of 1 plus 0 divided by 0 and natural log of 1 divided by 0, and this is 0 by 0. So this form is 0 by 0. This form is 0 by 0. L'Hopital rule says that if you get 0 by 0 form, you have to take a derivative. So we take a derivative, limit x approaches to 0, 1 over 1 plus x, the derivative of numerator and the derivative of denominator. Now we apply the limit again, limit x approaches to 0, we get 1. So x is 0, here x is 0, so 1 over 1 plus 0 divided by 1, so this is 1. So we solved a transformed problem, natural log of f of x is equal to 1. But our question was to find out the L'Hopital, find out the answer for this by using L'Hopital rule. So we have to take anti-log on both sides as I already explained over here, this thing. So we take anti-log on both sides, limit x approaches to 0, e raised to power natural log of f of x is equal to e raised to power 1. So anti-log and log will be cancelled out, natural log will be cancelled out. So we get net limit x approaches to 0, f of x is equal to e. And what was f of x? F of x was this term, so we put that term over here and we get the answer. So we get limit x approaches to 0, 1 plus x, 1 over x is equal to e. So that's how we solve the problem. The next question, which I already have written over here, is very interesting. You can see that this problem becomes, when we apply the limit, it becomes infinity and 1 over infinity, and infinity raised to power is 0, which is also indeterminate form. So the same thing we do, since we cannot directly apply L'Hopital rule over here, since there is only f of x and we cannot take a derivative of numerator and denominator. So we define f of x is equal to x 1 over x. Then we apply natural log on both sides, natural log of f of x, natural log of x 1 over x. Then natural log of x divided by x. Limit, then we apply the limit x approaches to infinity, x raised to power natural log of f of x, natural log of x raised to power 1 over x is equal to limit x approaches to infinity, natural log of x divided by x. Now when we apply the limit over here, you get that natural log of infinity is infinity and x is infinity, so this form is infinity by infinity. And we have f of x available for us, g of x is available for us, we can take a derivative. By L'Hopital rule, limit x approaches to infinity 1 over x and 1. When we apply limit, we get 0. Now we take antilog on both sides to get f of x. Applying antilog, limit x approaches to infinity, e raised to power natural log of x raised to power 1 over x is equal to e raised to power 0. Antilog and log will be cancelled out, so we have limit x approaches to infinity, x raised to power 1 over x, that will be equal to 1. So that is interesting. The limit for x raised to power 1 over x is 1. So this was the our second example, and you can see that now we can tackle such kind of indeterminate form. For such indeterminate form, remember that you first put your function f of x, you first put your expression and place it with f of x, replace it with f of x, then solve that problem by taking log and then antilog and so on and so forth. Thank you for watching.